Hello, this is the last video in a series I'm calling Fun Probability Calculations, and this one we're just going to call Probabilities Miscellaneous. Now all these problems are taken off actuarial exams, and more specifically off the actuarial exams that I have in a playlist called Free Actuarial Exams. So problem 1, Mr. Flowers plants 10 rose bushes in a row, randomly 8 white and 2 red. Find the probability that he will consecutively plant 7 or more white bushes. And so here's the answer. So to find this probability, we need the number of ways that we can have 7 or more in a row divided by the total number of ways that this can happen. Well, the total number of ways is 10 factorial divided by 8 factorial divided by 2 factorial, which is 45. Now this can be thought of as a multinomial coefficient, but you can also think of it as if you have 10 bushes in a row and you're randomly picking 2 of them for the red bushes, so it becomes 10 choose 2, and it's also the same calculation. Here, the way we're going to calculate the number of 7 plus in a row is we're just going to list them. Now a circle means a white bush and a square means a red bush. And I'm always going to put the 7 in a row in a circle, and we're going to list them. So this is one possible way. Then we can have the 7 first, then a red, then a white, then a red. 7, red, red, white, 7, white, and so forth. And so these are all the combinations that we can have. So 2 red, 8 white, red, 8 white, red, etc. But now I got one question for you. Is notice that I put the 7 in the third spot in only 2 cases. There's no other case where I have the 7 in the third spot. And here we have 2 reds in front, then the 7. And here we have a circle, the white bush, then a red, then the 7. Why didn't I switch those around and put a red bush, then a white, then the 7? Well, the answer is this. If we have a red, and then a white, and then 7, that's 8 whites in a row, which is actually what this case is. Red, 8 whites, red. And since order doesn't matter, that would be the same case as this. And so you have to be careful. So what this tells me is there's 1, 2, 3, 4, 5, 6, 7, 8, 9 ways that we can have 8 or more white bushes in a row. And so that tells me the probability is 9 over 45, which is 1/5. Now the next problem, we have a calculator. It has a random number generator button, which generates the numbers 0 through 9. The button is pressed 4 times. Find the probability of seeing A0, A5, and 2 9s in any order. Well, this is the classic multinomial problem. We're going to let xi be the number of the ith number, pi be the probability of the ith number, and right, there's 10 numbers, they're all equally likely, so it's 1/10 for every number. And then this is the multinomial setting, so it's n factorial over in 0 factorial, how many zeros we saw, how many 9s we saw, etc. Probability of seeing a 0 raised to how many zeros we saw for all 9 or 10 digits, P9, X9. So what we wanted was this. X0, 1, we want 1, 0. X5 is 1, so we want 1, 5. X9 is 2, we want 2 9s. And all the other x's are 0. So now when we plug them into this formula, we have 4 factorial, we have 1 factorial, 1 factorial, 2 factorial, and the others are 0 factorial, which are 1, so we can ignore them. And then here, P0 is 1/10 raised to the 1th, and P5 is 1/10 raised to the 1th, P9 is 1/10 raised to the 2nd, and the all others are 1/10 raised to the 0, which are 1s, which we'll ignore. So now to do this calculation, you come up with this. So problem number 3, we have n plus 1 slips of paper numbered 1 through n, and then the n plus 1 also has an n. So there's one number 1 through n minus 1, but then there's 2 slips of paper that have n on it. Now we want to n samples with replacement. Find the probability that the numbers recorded in any order are 1 through n. So here it is. This is a classic multinomial setting. If we let xi be the number of slips with the number I on it, then this becomes the probability. And so it's the multinomial setting. So each one of these is a 1. So this coefficient is n factorial divided by 1 factorial times 1 factorial times 1 factorial, which are all 1, so you just have the n factorial out front. Now the probability that the slip of paper has a 1 on it is 1 over n plus 1. And we want one of them, so it's raised to the 1. And this is the case for all up to n minus 1. The probability that we draw a slip of paper with n minus 1 is 1 over n plus 2. And we only want one of them, so it's a 1. Now here, the probability that we draw a slip of paper with an n on it, is 2 out of n plus 2. And raised to the 1th power. So now when you multiply all these together, you get 2 times n factorial over n plus 1 raised to the nth power. That's the probability. The last problem, number 4, we have a softball league with teams of 5 women and 5 men. The batting order must have a woman first and then alternate by gender. How many different batting orders are possible? Here's the solution. And this is the way that I like to think about it. Each box represents a batter. So there's 10 boxes. The first one has to be a girl, or I probably could have put woman. G for girl, B for boy, instead of M and W. I don't know why I did that, just did. So there's 5 girls or 5 women that could be chosen for this first spot. The second one has to be a boy, and there's 5 boys, and so there's 5 possibilities. This next spot has to be a girl, and there's only 4 left, so there's 4 that we can pick there. 4 boys, 3 girls left, 3 boys, 2, 2, 1, 1. And when you multiply these, you get 5 factorial times 5 factorial, which is 5 factorial squared. And that's it. And that's all I have for this video. Hope you enjoyed that. I sure did. Please like the video and subscribe so you don't miss the next one. Thanks. Bye.